Hi everyone, my name is Jesus Pulido, but I go by Jay. Today I'll be doing my second video for dynamics. For this presentation, I analyzed a real-world scenario where I recorded an SUV making a left turn. And I'll set up the problem today to determine the centripetal acceleration and then the required friction force for this specific turn. So here's our problem. An SUV with a mass of 180 kilograms enters a left-hand turn with a constant radius of 30 meters. Based on the video, the vehicle speed during the turn is 12 meters per second, right? And the coefficient of static friction between the tires and the road is mu is equal to 0.85. The distance between left and the right tires track width is 1.6 meters, and the center of gravity is 0.8 meters above the ground, the center line of the vehicle. So we need to determine the centripetal acceleration and the required friction force, as well as the safety margin. Here's the video. So our given and assumed, we have a mass of 1,800 kilograms. Our turn radius is 30 meters. Our velocity is 12 meters per second. The coefficient of friction is mu is equal to 0.85. Track width is d is equal to 1.6. The height is 0.8, and then the gravity is 9.81. And then we assume constant speed, circular path, rigid body, and then level road surface to apply our dynamics equations. So here we have our free body diagram as well as our inertia diagram. And in our free body, we have the car being pulled down by the mass and gravity. We also have our acceleration, the centripetal acceleration that points to the middle of the circle. We also have our acceleration tangential, which is pointing up front. And then we have the resultant force that is from both of those. In our inertia diagram, we have the centripetal acceleration pointing towards the center of the radius. And again, these diagrams will be equal when we apply Newton's second law. Finally, the equations that we're going to need is the centripetal force, which is going to be Fc is equal to mv squared over r. Our friction check, make sure that it is sticking to the ground, so it's going to be that centripetal force times is going to be less than or equal to the mu times the mass times gravity, and then the moment balance, which is making sure that it stays on the ground. And we're going to compare these two together in order to make sure that it does. So yeah, thank you.